Somewhere past the orbit of Pluto, past the edge of everything we call home, a machine older than the internet just did something that made NASA's own engineers stop and stare at their screens in silence. Not excitement, not celebration. Silence. Because what Voyager 1 sent back was never supposed to happen, and the story of why it happened is stranger and darker than almost anyone outside a small room at NASA's Jet Propulsion Laboratory has been told. Here's the moment you need to understand first. Voyager 1 is right now more than 25 billion kilometers from Earth. That's over 15 billion miles. A number so large, your brain simply refuses to hold on to it. So let's make it real. If you sent a text message to Voyager 1 right now, it would take over 23 hours just to arrive. Not seconds, not minutes. Almost a full day, one way, through the freezing dark. And when the spacecraft replies, that answer takes another 23 hours to crawl back to Earth. A single hello and a single "I'm still here" between us and this machine costs nearly 2 full days. There is no live conversation happening. There never can be again. Every command NASA sends into that void is a message thrown into the dark, hoping something on the other end is still listening. And for a few terrifying hours back in February 2026, engineers genuinely weren't sure it was. During a completely routine scheduled roll maneuver on February 27th, the kind Voyager 1 has performed without incident for decades, the spacecraft's power levels dropped in a way nobody had planned for. Not a small dip, an unexpected one. And here's what that word actually means when the machine in question is 49 years old and utterly alone. It means the people, who understand Voyager 1 better than anyone alive on Earth, were watching numbers behave in a way their own models didn't predict. At a distance where fixing anything in real time is not just difficult, it's physically impossible. If that power kept falling, Voyager 1's own onboard computer, ancient by any modern standard, would have triggered something called the undervoltage fault protection system. It's not a gentle shutdown. It's a blunt, automatic self-preservation reflex built into the spacecraft's code back in the 1970s by engineers who somehow anticipated that one day, decades later, their creation might have to save itself with nobody able to help in time. If that system had taken over, recovering from it would have required what NASA itself calls a lengthy process that carries its own risks. In plain language, the fix could have been worse than the problem. So on April 17th, 2026, NASA's engineers did something almost unthinkable. Before the machine could sacrifice itself blindly, they chose the sacrifice themselves. A command traveled nearly 23 hours across empty space, instructing Voyager 1 to permanently power down an instrument called the Low Energy Charged Particles Experiment, or LECP. Confirmed directly by NASA's Jet Propulsion Laboratory, this instrument had been running almost without interruption since 1977, since Jimmy Carter was in the White House, since disco was still on the radio, since the very idea of the smartphone in your pocket. Right now would have sounded like pure science fiction. And on that day, by human choice, it went dark. Now, here's why this single decision matters more than a dead sensor on an old machine. The LECP measured low-energy charged particles, ions, electrons, and cosmic rays drifting in from both our solar system and deep within the galaxy. It gave scientists their clearest window into the true structure of interstellar space, the invisible region where the sun's influence finally loses its grip on the universe. Voyager 1 and its twin Voyager 2 are still, right now, the only 2 spacecraft ever built that are far enough out to measure any of this. There is no backup. There is no second mission quietly waiting in the wings. When that instrument went silent, humanity may have lost, possibly forever, one of its only working eyes on a frontier no other machine has ever touched. But this is where the story most people have heard stops. It's exactly where the real story, the one almost nobody is talking about, actually begins. Because the shutdown in April wasn't an isolated crisis. It was one visible symptom of something much larger that NASA has been managing in near total silence for years. And in the middle of trying to keep the spacecraft alive by any means necessary, something came back through Voyager 1's ancient instruments that even its own principal investigators did not expect. Something that reframes everything we thought we understood about what this dying machine is still capable of finding out there in the dark. To understand what Voyager 1 sent back that nobody expected, you first have to understand exactly how much of this spacecraft has already been sacrificed to get this far. Because the April shutdown wasn't the first cut, it wasn't even close. Both Voyager 1 and Voyager 2 launched in 1977, carrying 10 identical sets of scientific instruments, 10 separate eyes and ears, built to study planets nobody had ever seen up close. As confirmed by NASA's own mission updates, 7 of those 10 instrument sets have now been permanently shut off, one at a time, over decades, not because they broke, but because engineers made a calculated choice to kill them before the cold and the dark could kill the whole spacecraft first. Think about that number, sitting in the void, 7 out of 10. a machine that once carried a full suite of scientific senses, stripped down piece by the deliberate hand of people trying to buy just a little more time. And the reason for all of it comes down to one brutal, unchangeable fact of physics. Voyager 1 runs on 3 radioisotope thermoelectric generators, devices that turn the heat of slowly decaying plutonium-238 into electricity. There is no refueling a spacecraft 25 billion kilometers from Earth. There is no technician who can fly out and swap the battery. According to NASA, the spacecraft has been losing roughly 4 watts of power every single year since launch, a quiet, relentless drain that cannot be paused, slowed, or reversed by anything humans have ever built. At launch, Voyager 1's power source produced close to 470 watts. Today, after nearly 50 years, that number has fallen to roughly half its original strength. Every year that passes, the list of things this spacecraft can still do gets shorter, and every year, the choices facing the people managing it get harder. This is the part that never makes the headlines, because it doesn't fit neatly into one dramatic moment. The real story of Voyager 1 in 2026 isn't a single catastrophic failure. It's death by 1,000 quiet, calculated decisions, made one at a time, by a small team at JPL who know that any single choice could be the one that finally ends the longest-running space mission in human history. Turning off a heater saves precious watts, but it risks a critical component freezing solid in the roughly minus 270 degrees Celsius ambient temperature of interstellar space. A cold so extreme it sits only a few degrees above the coldest theoretical temperature possible anywhere in the universe. Every heater NASA switches off is a bet against physics itself, wagering that 50-year-old hardware built before the microprocessor even existed will somehow keep functioning in conditions that would instantly shatter almost anything else humans have ever engineered. And yet, against every reasonable expectation, that bet has paid off in a way nobody predicted. When engineers powered down the heater protecting the very instrument they eventually sacrificed in April, its small stepper motor, the mechanism that physically rotates the sensor to scan in different directions, kept working even as the surrounding temperature plunged to roughly minus 62 degrees Celsius, according to NASA's own reporting on the shutdown. That motor had already logged nearly 8.5 million steps across almost 49 years without failure, and it simply refused to stop, even after losing the heat that was supposed to keep it alive. Matt Hill, the LECP's principal investigator at the Johns Hopkins Applied Physics Laboratory, said the team is holding out hope that engineers can still find a way to bring the instrument back to let it, in his words, keep learning whatever surprises await Voyager in these distant regions of space. Because here is what almost nobody outside specialist space coverage has connected yet. This isn't the first time Voyager 1 has quietly handed scientists something they never expected. Years earlier, a Cornell-led research team studying archived data from the spacecraft's still-functioning plasma wave instrument discovered something genuinely strange. A faint, steady, narrow-band hum coming from the empty space between the stars. Unlike the sharp, short bursts of plasma oscillation triggered by solar shock waves that scientists had studied for decades, this signal was different. It didn't spike and vanish. It persisted quietly, continuously, for years, with no clear connection to anything the sun was doing at all. Researchers published the discovery in Nature Astronomy, describing it as a previously undetected class of very weak plasma wave emission, one that let them measure the density of the interstellar medium continuously for the first time, instead of only during rare, violent solar storm events. Stella Koch-Ocker, the Cornell researcher who led the discovery, called it almost entirely unexpected. Nobody built Voyager 1's instruments to find this. Nobody was looking for it. It was simply there, humming quietly in data the spacecraft had been sending home for years, waiting for someone on Earth to finally notice. Now hold both of these facts in your mind at the same time. The spacecraft engineers are actively, deliberately dismantling piece by piece just to keep it breathing. And that same spacecraft, even while being stripped down to its bones, is still finding things in the dark that nobody on this planet anticipated. The tension between decline and discovery, between sacrifice and revelation, is exactly what sets up the next chapter of this story. Because in the middle of trying to save Voyager 1 from silence, NASA is now running an experiment so risky, so unprecedented, that they refuse to even attempt it on Voyager 1 first. Here is where the story stops being about patience and starts being about a gamble. A real one, with no safety net, being run on a machine that cannot be repaired if it fails and cannot be replaced under any circumstances, because there is no factory on Earth quietly building a second Voyager. There never will be. NASA's engineers have nicknamed this plan almost too casually for what it actually represents: the Big Bang. Confirmed directly by NASA and reported by CNN and Live Science, the idea is to swap out a whole group of powered components on the spacecraft all at once, turning some things off permanently while switching on lower power alternatives, all in a single coordinated maneuver designed to buy the Voyager mission's real, extended life. This isn't a routine software patch. It's closer to performing surgery on a patient you cannot see, cannot touch, and cannot check on for nearly 2 full days after you make the first incision. And because the stakes are absolute, NASA is not testing this on Voyager 1 first. They're testing it on its twin. Voyager 2, which has slightly more power to spare and sits somewhat closer to Earth at roughly 21.3 billion kilometers away, was chosen as the safer test subject, with the Big Bang fix scheduled to run during May and June of 2026. Only if that test succeeds will engineers attempt the same maneuver on Voyager 1, no sooner than July, according to NASA's own timeline. Sit with the psychology of that decision for a second. 2 machines launched within weeks of each other back in 1977 have spent nearly 50 years flying alone in almost total isolation, drifting farther apart with every passing year. And now, in the middle of 2026, their fates have become linked in an entirely new way. One spacecraft is being used to test a risky, experimental fix specifically, so that its more fragile, more distant sibling doesn't have to be the one that fails first. If the test succeeds, and the same fix works on Voyager 1 later this summer, there is a real chance, however small, that the very instrument NASA sacrificed back in April, the LECP, could be switched back on. Mission engineers estimate that shutting it down in the first place bought Voyager 1 roughly 1 additional year of operation, possibly stretching the mission far enough to reach its full 50th anniversary. If the Big Bang fails, that instrument likely stays dark for good, one more quiet. Loss folded into a much larger story of managed decline. Either outcome will be decided in the coming weeks, not decades. This is happening right now in the summer of 2026, largely outside the awareness of most of the world. And while all of this unfolds in the background, Voyager 1 is racing, quite literally, toward a distance that will redefine what the word far even means for anything humans have ever built. NASA announced that Voyager 1 will cross 1 light day from Earth on November 18th, 2026, the exact distance it takes light itself, the fastest thing in the entire universe, a full 24 hours to travel. That's roughly 25.9 billion kilometers, or about 16.1 billion miles. Stop and actually sit with that. Not 1 light hour, not 10, a full light day. If you could somehow travel at the speed of light, the literal cosmic speed limit of reality, it would still take you an entire day just to catch up to where this 49-year-old machine currently sits in the dark. Suzanne Dodd, Voyager's project manager at JPL, has described what that distance actually means in painfully human terms. If she sends a message to the spacecraft at 8 a.m. on a Monday, she won't hear anything back until roughly 8 a.m. on Wednesday, a 2-day round trip for a single sentence. And remember, this is a spacecraft whose 3 onboard computers share only 68 kilobytes of memory combined, running processors clocked at a mere 250 kilohertz, less raw computing power than a basic modern calculator. Commands travel up to it at only 16 bits per second. Its science data crawls back to Earth at roughly 160 bits per second, something like 500,000 times slower than an average home internet connection today. And despite all of that, despite the cold, despite the failing power, despite hardware built before anyone alive today's parents had personal computers, it is still listening, still answering, still somehow finding things nobody expected it to find. NASA projects that sometime in the early 2030s, both Voyager probes, will finally lose enough power to operate even their last remaining instruments. When that threshold is crossed, the spacecraft will go silent forever, still moving, still carrying humanity's message outward, but no longer speaking back. There will be no dramatic final transmission, no warning, just an ordinary day when the signal that has come home every single time for nearly 6 decades simply doesn't arrive, and won't arrive again, ever. So ask yourself the question that's been sitting underneath this entire story. If a dying, half-blind, nearly 50-year-old machine, stripped of 7 of its original 10 senses, running on a battery that cannot be refueled, still managed to hand. Scientists, mystery nobody was looking for. What else is it quietly sending home right now? Data nobody at NASA has finished analyzing yet? Here is the piece of this story that should genuinely unsettle you, because it isn't science fiction, and it isn't speculation. It's sitting in NASA's own data archive right now, still being pulled apart by scientists who are honest enough to admit they don't fully understand it yet. That persistent plasma hum discovered in Voyager 1's data wasn't a one-time fluke buried in old records. Researchers studying the spacecraft's plasma wave system found that this faint, continuous signal has kept showing up since 2017, allowing scientists, for the first time, to track the density of interstellar plasma almost continuously, rather than only during the rare, violent moments when a shock wave from the sun happened to pass through. In more recent analysis of Voyager 1's Magnetic field data, published in the Astrophysical Journal in 2026, has continued tracking something researchers are calling a magnetic hump, an unusual extended feature in the very local interstellar medium that Voyager 1 first entered in 2020 and is, remarkably, still moving through in 2025 and into 2026. Scientists still don't have a fully settled explanation for what's driving it. That's not a headline exaggeration. That's the honest, current state of research, published in a peer-reviewed journal, about a region of space that literally no other human-made object has ever reached, let alone studied for this long. So when people ask what Voyager 1 wasn't supposed to see, this is the honest answer. It was never built to detect a slow, unexplained hum in the empty space between stars. It was never designed to track a magnetic anomaly that lingers for half a decade in a region scientists assumed would behave in far simpler ways. Its own principal investigators are on record, saying discoveries like this are almost entirely unexpected. And now, in the middle of 2026, the very instrument capable of studying charged particles alongside these anomalies, the LECP, sits dark, deliberately silenced, waiting on the outcome of an experimental fix that engineers are testing on its twin thousands of light seconds closer to home. Every additional watt saved by that April shutdown is a watt spent buying time for scientists to figure out what exactly is humming out there in the dark. This is the tension that defines the entire Voyager mission right now, in this exact moment, not in some distant future. Spacecraft is being methodically dismantled by the humans who built it, instrument by instrument, heater by heater, because that's the only way to keep it alive even one more year. And yet the same spacecraft, even stripped down to a fraction of its original capability, keeps handing scientists mysteries that rewrite what we thought we knew about the true edge of our solar neighborhood. Nothing about that is a coincidence. It's the direct result of squeezing every last watt of usefulness out of technology that was engineered in an era of slide rules, punch cards, and rotary phones. Hardware nobody expected to survive this long, let alone still be making discoveries. And the clock underneath all of it has never stopped running. NASA's own projections say both Voyager probes will lose the power needed to run even their last instruments sometime in the early 2030s. Once that happens, there's no recovery, no restart, no second chance. The spacecraft will keep moving silently, carrying its golden record and its faint radio silence out into deeper space, but it will stop talking to us forever. In roughly 300 years, Voyager 1 will reach the inner edge of the Oort cloud. In roughly 30,000 years, it will finally clear the outer edge of that same cloud and leave the sun's gravitational influence behind entirely. Every person alive on Earth today, every language currently spoken, will very likely be gone long before this spacecraft even finishes leaving our solar system. Its silence in the 2030s will only be the very beginning of a journey that stretches so far into the future that measuring it in human years starts to feel almost meaningless. So think about where that leaves things right now in July 2026. Engineers just wrapped up testing an experimental high-risk revival procedure on Voyager 2, with a decision on whether to attempt the same fix on the far more fragile. Voyager 1 expected any time this summer. An instrument silenced in April may or may not come back online in the coming weeks. A hum nobody planned for is still being studied in archived data nobody has finished going through. And in November, Voyager 1 will cross a threshold no human-made object has ever crossed before, becoming, for the first time in history, genuinely, measurably, a full day away from everyone who has ever known it exists. Somewhere out past the edge of everything familiar, drifting through cold that would destroy almost anything else humans have ever built, a machine that is half-blind, stripped down, and nearly 50 years old, keeps sending its faint signal. Home, and it keeps finding things nobody told it to look for. The real question nobody can answer yet is simple. If Voyager 1 already found something this strange while dying by inches, what happens if the Big Bang fix actually works? And this aging, stubborn spacecraft gets a little more time to keep listening to whatever else is out there in the dark? If this story pulled you in the way it pulled me in while researching it, hit subscribe, because the next update on Voyager's fate could come at any moment this summer, and you'll want to be here when it does. Drop a comment and tell me, do you think NASA should risk the Big Bang fix on Voyager 1, or let the mission end quietly on its own terms? I'll read every single one.